Welcome to our NLP class. This is part 13. In this class, we are going to study about word embedding. What is word embedding? It is again the numerical representation of our textual information. In our NLP model, this NLP model has its mapping function f of x. X should be a numerical vector given to this f of x. Then it would predict this y prime. Here our input raw input is in terms of textual format, all textual information. Then now we have seen in our earlier classes how to convert this text into the numerical vector. So, we have seen several methods. Now, in this word embedding approach, there are simple techniques how we can identify the distance between words, For example, if there are two words, word 1 and word 2, there are some techniques by which we can measure the distance between these two words. So, it is interesting concept. Then before just looking into the techniques, we can just ask the questions ourselves. Why do we need to measure the distance and how do we measure the distance? For the first question, what is the need for measuring the distance? Two words, for example, there are two words like vanilla, ice cream. Just by looking at this flower, it is a plant name or flower name, and ice cream is a dessert. How do we measure the distance between these two words and what is the need for it? So, nowadays in recent days we are hearing about ChatGPT. So, everywhere we are talking about ChatGPT. It is actually a deep learning NLP model. So, in this class we are studying about NLP basics. We are not learning about deep learning techniques. When we start learning a deep learning technique, then we will see how to implement deep learning NLP models. So, ChatGPT is also a kind of linguistic model, deep learning NLP model. It generates sentences and words. So, the ChatGPT learn from millions or trillions of documents and data, and now when this is our training data, and it learned based on the training data, and now after now we have the trained ChatGPT. For this ChatGPT, when we pose a question, it generates sentences and words and documents. So, there is a model called generative model in the deep learning NLP. We will learn more about these techniques later. So, this generative models needs to understand the sequence of words. What is the relationship between word 1 and 2? What is the relationship between vanilla and ice cream? What is the relationship between queen and king, or boy and girl? So, the relationship between these two words and also the distance between these two words. Based on this understanding, the ChatGPT would generate sequence of words. Just it would generate first word, and then just looking at the relationship between the first word and what should be the next word for the given context, for given question what we ask to ChatGPT. Now, we know that importance of understanding the relationship between two words and the distance between two words. Then next question is how we measure the distance. There are simple techniques. First we will see first technique, which is actually understanding that association between words. So, let us consider an example. There are three sentences, S1, S2 and S3. The first sentence is, I like vanilla ice cream. I like vanilla ice cream. And second sentence is, I like plain vanilla ice cream. And third sentence is, I like vanilla milk ice cream. Let us assume that this is our entire corpus and these are the total words in this entire corpus. Based on this information, we are going to see the relationship or distance between the word ice cream and the remaining words in this corpus. In order to do that, we need to create a grid with size. It could be either 2 or 3 or 4. So, let us assume that we will create a grid of size 2. When we use this grid, it is just like a lens. So, when we use this lens, it just look at only nearby 2 words. So, now we have ice cream in all 3 sentences. Now, we are going to see what is the distance between ice cream and the remaining words. Since we are using the grid size of 2, our grid can go up to 2 words before or after. So, from ice cream, the grid can reach up to this like. It cannot read I. From here, it can go up to plain. And from the third sentence, the ice cream word can go up to vanilla. Now, we know the grid. Within this grid, we will see the distance. First, we will see our features. This, what are all the words in this sentences? I like vanilla and then plain, here milk. Now, we are going to measure the distance from ice cream. What is the distance from ice cream to I? Here none of the word is within this grid, none of the sentence. Here this I in all 3 sentences are outside the grid, it is outside the grid. So, the distance we just put this, there is no relationship, just we put 0. And between ice cream and like, here the from the first sentence it is at the distance 2, from the second distance there is no distance, 0 and 0, and we will take this highest value 2. And vanilla, here it is at a distance 1 and first one it is at a distance 1 and third sentence is at a distance 2. I will take the highest distance. And for the word plain, it is also 2. For the word milk, and the distance is 1. So, this is how we can create the relationship, the distance between this is a simple way of measuring the distance in a single dimensional space. And another way we will see one more method, just in a 2-dimensional space, the relationship between documents based on some words given in the document, more frequently appeared word in the document. Let us assume there are 3 documents we are considering. First document is about machine learning. And second document is about manufacturing. and third document is forming. So, here what we are going to do is we are going to see what is the relationship between these three documents and how close these three documents are. So, let us assume that there are two words, we are just looking at two words, robot and data. We will see the frequency of these two words in the first document. Let us see, the robot appeared maybe 200 times and the data appeared 600 times in this document, and see the robot appeared maybe 300 times in the document manufacturing and 500 times, and see the robot appeared 20 times in the document forming and data appeared 550 times. Now, can we visualize this information? These are all numerical vectors, two dimensional vector. So, we can place this two dimensional vector in a 2D plane. How we can do this? Just take a 2D plane and consider the word robot in x axis and the word data in y axis, and let us assume this, we will position these numbers in x axis, y axis. This is maybe 50, 100, 150, 200, 250, 300, etc. Similarly, here in y axis we place this maybe 100, 200, 300, 400, 500 and 600. Let me erase this little bit here. Now, let us position these words on this 2D plane. How do we represent the document machine learning? It is 200 and 600. $500, 600. It's 200 and 600. It would be coming here. $200, 600. It would be coming here. This is our document machine learning. And next one is manufacturing, which is 300 and 500 here. This is the document manufacturing. And next one is farming. This is 20 and 550. This is 20 and 550, somewhere here. So, these are the three vectors. This one is farming. Just by visualizing these three words on this 2D plane, now we can see how close these three documents are. Just by looking at these three documents or 3 point on 2D plane, we can see this machine learning document is closer to manufacturing than farming. Farming is far from these two documents. This can be measured by two different ways. The exact distance can be measured by just by Euclidean distance, measuring this distance, or cosine similarity, this cos theta. either we can measure this sin theta. In our next class, we will see how to measure this Euclidean distance and cosine theta. I will see you in next class. Thank you. Bye.